Okay. Good morning, good evening, everyone. Thanks for attending the session. So first, let me introduce myself. Shivkumar. I have 10 plus years of experience in IT. I started my career with the ETL tools, that is ODI, and after that, I worked with the different ETL tools like ODA, OBA, and the bit of Informatica. And after that, I got a chance to work with the Matillion. After that, I got into big data most of the time. And after that, I got a chance to work with the Snowflake and the currently AWS and the currently I'm working with the Snowflake and the Azure part completely. Okay, so that is pretty much about myself. Okay, so let's get into the demo part. Okay, so before you guys attending the session, at least you guys could have like inquired about what is Snowflake, how is the market, and how the opportunities are there outside. Uh, at least you could have done a little research, right? Okay, so based on that research, like what did you understand? I mean, what is Snowflake exactly? Is it a database, or is it a like data warehouse, or it's an ETL tool, or what exactly it is? Okay, so I'll go with I'll give you the answer for that. Okay, so if somebody asks you, hey, what is Snowflake? I would say that it's a data warehouse. Okay, after that, I mean, in the next slide, I would say that it is a like database as well. Snowflake, we can use it as a database as well. Okay, so here basically, it's a cloud data warehouse, I can say. It's not an on-premise database. We don't have any on-premise Snowflake kind of thing. So it's a purely cloud. So if it is a cloud, what kind of service it is? In cloud, many of you know that we have SaaS, PaaS, IaaS, and different services are there, right? Now, Snowflake comes into which category? Is it comes into like IaaS or PaaS or infrastructure as a service or platform as a service or SaaS, that is software as a service? Which category it comes under exactly? So I would say that Snowflake is a SaaS. Okay, I'll tell you guys what exactly mean by this PaaS, SaaS, and IaaS later, not now. But as of now, you just try to understand it is a SaaS solution. Snowflake is a SaaS. So in SaaS, what do we do? You don't need to install anything from your side. You don't need to do anything from your side. Your side. Everything is provided by cloud provider. You need to create an account with them and you just start using it. That's it. Nothing to do with that tool. Nothing to do with that application. Okay. Now the conclusion point is Snowflake is a cloud data warehouse and it comes under SaaS category. Okay. Now, Shiva, tell me, you told me that like you told us like it's a data warehouse, right? So you're saying that it's like a database as well. Yes, boss. Recently, they announced and they made it public, and they say that recently, very recently, they say that Snowflake can be used as database as well. That means Snowflake can be used as OLTP as well, and it can be used as main purpose of this one is OLAP, that is online like analytical processing, that is data warehousing. Okay, so let me tell you what are all the different like OLTP or OLAP tools are available, or like data warehouse tools are available in the market. So I would say that the competitors for Snowflake is if I come through the if I try to compare with the cloud, right? Amazon Redshift is a competitor for this. Okay, Synapse Analytics from Azure side is a competitor. Okay, Teradata is a major competitor for Snowflake. Of course, Teradata is a like on-premise one. Snowflake is a cloud one. So most of the clients are like companies are moving from Teradata to Snowflake. Okay, so that is it is a competitor for all those like OLAPs, I can say. Okay, now, so what else? You are mentioning that it is an OLAP, right? What else it can do? Snowflake can be Snowflake is acting as currently semi ETL tool. I mean, it is not a fully fully ETL tool, I can say. I mean, we don't have any mechanism to drag and drop the things and we can create a pipeline here. No, we don't have such kind of thing here. Snowflake is just a semi ETL tool. That means we can build the pipelines, not with the like UI. So we have to deal everything with SQL commands only. That is where I'm saying it is like a semi ETL tool. Okay, I cannot compare the Snowflake with the traditional ETL tools which are available in the market. It is just a semi ETL tool. That's it. Okay, that is fine. Guys, please give me some time. I mean, I'll try to answer your questions. Okay, I'll continue the session first. I'll give you some time. I'll give you time to ask the questions. At that time, we'll discuss. Okay, yeah, moving on. Next, where exactly we can use this Snowflake in traditional like data warehouse architecture? Okay, see here. I mean, let me try to explain the traditional ETL architecture here. And after that, I'll try to talk about where exactly we are going to use this, where exactly it is going to fit in this architecture. Okay. Now, many of you know that this is ETL architecture. Many of you know that ETL is nothing but extracting, transforming, and the loading. Extract, transform, and then load it. Okay. Now, extraction is nothing but what? We generally extract the data from different sources. If you take any organization, any company, they store their data in multiple sources. They may store their transactional data in OLTP. They may store their data in their own enterprise applications. Okay. They may store their data in third-party applications. They may store their data in a web applications. I mean, they may get the data of like web applications. They may store their data in a cloud as well. So you can get the data from anywhere, any of these sources. Now, what we have to do is, I would say that all these are OLTP, online transactional processing. OLTP full form is online transactional processing. Okay, let me tell you what exactly I mean by that. Okay, so if any of the database is attached to application, then we call the database as OLTP. So if it is attached to the data application, why do we call it as a OLTP? Okay, let me tell you one best example. If you go to any store, like retail store, what do? They'll scan the items, whatever you purchased. And they'll scan your card also, membership card also, and they'll try to bill the items against your card. That is one transaction. Okay, so how many items he purchased? What are all the different categories of items he purchased? What is the total what is the total billing? How many times he visited in last in this month? That visit number, everything they will capture in the backend. That is nothing but transactional data processing. So since we are capturing each and every transaction related to customer or like any transaction, we call that as a OLTP, online. That means immediately we are capturing, on real time we are capturing online transactional processing. Where do we store the data? In a database. Okay, back end, when you go to retail store, when you go to any hospital or when you go to any organization, they'll try to they'll try to take your details and they'll try to enter your details in their application. And back end, that data will go and sit in a database only. And whenever you go next time, right, they'll ask you, hey, what is your name? What is your Aadhaar card number? What is your SSN number? What is your when did you visit last time? Can you tell me last case number? And they'll ask you such details actually. So if you give such those details, they'll try to get your details from the backend database. So such kind of databases, we call it as a OLTP. Now Snowflake can be used as OLTP. Okay. Okay. Now, once they have the data in OLTP or other applications, what do we do? What do we do? So if they keep on storing the data in their backend database, what is the use of that actually? They have to analyze their data, right? Let's say one customer is continuously visiting their store. Every week he is visiting actually. Now they wanted to send some promotional codes to that guy. Some promotion they wanted to give some discount to that guy because he's making business to them. Then how do they come to know that this guy is visiting frequently? So they have to build some analytics out of that. They have to analyze their data. To analyze that one, they have to first extract their data using any of the ETL tool. Okay. After extracting, if they extract, that is enough. No, they have to transform the data. Let's say, let me tell you one best example generally I used to give to the students is, let's say, if I take customer table, let's say my business wanted to analyze their business based on like age, which age group people are visiting their store, which age group people are like purchasing their products more. That's what they wanted to analyze in the backend in the OLAP. So in that case, when you go to store, will they capture your date of birth or will they capture, they will ask you your like age. They'll ask you only your date of birth. That's it. What is your customer name? What is the date of birth? That's it. Now, with the help of like date of birth, how do they capture the age? Now, current year minus date of birth year. So that you'll get, what you'll get actually? Age of the customer. So from that, age group you will not get again. When the age is between 13 to 19, then age group is teenage. When the age group is greater than 20, then greater than 20 and less than 35, then we call it as a middle age. Okay. When the age is greater than 35, like let's say semi middle age, like that, we have to categorize that ages actually. So that we call it as a transformation. We have to do those transformations. Let's say, and one more example let me give you here. We capture, when you go to store, generally they capture your first name and last name, right? But my business wanted to analyze that data based on full name. So we have to concatenate the first name and last name, right? For that. So that concatenation is also a transformation. So we have to do such kind of transformations here. And after that, we have to load the data into enterprise data warehouse. That is into separate database. That we call it as a EDW, enterprise data warehouse. That means I am trying to like capture the data from OLTP and I'm trying to load that, ultimately loading the data into data warehouse. This one we call it as OLAP. OLAP. The full form of this one is online analytical processing. Okay. So Siva, what is the example of this OLTP? Snowflake is the best example, boss. What are all the other like OLAPs are available in the market? Redshift is there, Synapse Analytics is there, and your Teradata is there, very famous one, and your Netezza is there, and Oracle is there, SQL Server is there. All these are like traditional OLAPs, I would say. So ultimately, you have to load the data into EDW only. That is our goal as being a ETL developer, being a data engineer. That is our responsibility actually. That is our goal actually. Now, after that, what do they do with that data? Directly, they can build the reports on top of that one. Okay. Sometimes what do? We have to divide the data into small data marts. Now, what is this data mart, Siva? What is this data mart? Okay. Let's say I have an organization. In that organization, different departments are there. Procurement department is there, finance department is there, like HR department is there, and sales department is there. Like the different departments are there. Marketing is there. Now, I don't want to make it clumsy by putting all my tables in one single OLAP. What I'll do is I'll try to segregate logically the tables into one small like category, I can say. That we call it as a data mart. All HR tables, I'll try to put it in one place. All finance related tables, I'll try to put it in one place. All marketing related tables, I'll put it in one place. Logically, I'll try to do it, not physically. Logically, they'll try to divide that one. But ultimately, in the back end, all these tables are related to each other. So based on your business, we have to divide the tables logically. That logical group of tables, we call it as a data mart. Now, on top of this data mart or on top of this data warehouse, we have to build the reports and dashboards. What is this report, Siva? What do they do actually? They analyze the business actually. What is that analysis they do? Hey, how much profit we got in last month? How much loss we got? How many how many customers visited last month during the festival time or during non-peak hours? What is happening in my business? That is what they are going to analyze with the help of BI. That is they try to analyze with the reporting tool. The example for this reporting tool is Power BI, Tableau, ClickView, ClickSense, like that, QuickSight. There are multiple tools are available in the market. So we have to build reports and dashboards with the help of that. Okay, so this is the traditional ETL architecture. Now, in this architecture, where exactly we are going to use our Snowflake, boss? Okay, the Snowflake will come and sit in this place, I can say. But Siva, you mentioned this will act as a semi-ETL tool also, right? Yes. Yes. Okay. Now, what do I do is I'll just try to I'll just try to show you one more diagram here. That is just a second. Sorry. That is this one. Now, these are all the activities can be done by Snowflake. That means I told you, right? This can act as a ETL tool as well. And this can store the data in a EDW. We can build EDW at enterprise level. We can build the data marts as well. And we can build these small reports as well with the help of Snowflake as well. And we can build the data lake as well. I'll talk about this data lake later, not now. We'll get into very deep about into data lake. Okay, that is the the purpose or the placeholder of the Snowflake, I would say. Okay, next. Same thing I'm trying to say here. So we can extract with the help of Snowflake, we can extract the data from different sources. Like all these are sources actually. And we'll try to put the data into staging. And on top of that one, we'll build the data warehouse. And on top of that one, if required, we'll try to build the data marts and we'll give it to the reporting team. Or we can directly share the data to the business users. Okay, same thing I'm trying to show in a different way. That's it. Okay, next, moving on. Shiva, Snowflake came into the market, that's okay. Now, why it has become very famous? Why it is like people are using it more? Can you tell me some differences? Can you compare with the traditional databases which are available in the market? So that we'll come to know. I'll get a clarity why I have to learn Snowflake. Okay. Yes, boss. I'll do that one now. The first one is performance. Snowflake is much will give performance when you compare with the other traditional data warehouses. Trust me, guys. 6 months back in our company, in our organization, we have literally proved to one of the client, Snowflake is much better than Azure Synapse Analytics. In a cost point of view, on the performance point of view, and the speed point of view, I can say, and the development point of view as well. We have proved that Snowflake is much better. We have taken 5 GB of data and we have loaded the data into Azure Synapse Analytics, and we have loaded the same data into Snowflake, and we have compared the speed and the performance between your Synapse Analytics and the Snowflake, and we have demoed to the customer, and customer was very happy. And finally, they have chosen they went with the Snowflake. Sorry. Someone is asking to.
Yeah.
I'll give you time, guys. Sorry, I'm muting you. I'll give you time to ask questions. Okay, moving on. Sorry. Okay, go on mute, please. Please. Don't interrupt in the middle, please. Yeah. Okay. So performance point of view, like even see, I have like almost 10 plus years of experience. I mean, in the complete into IT. I started my career with the database, guys. When I started my career, I worked with the Oracle database. At that time, to query the data from like to query 1 million records, we used to struggle a lot, and we used to fed up with the Oracle database actually. When we try to use Oracle as a data warehouse. When I started using Snowflake as a data warehouse, the data performance and the output of the Snowflake when you query some data from the Snowflake, the data was giving just like that. The output we are getting just like that. And when I first time when I queried the data from the Snowflake, when I was practicing, I felt very happy, and I predicted that Snowflake will reach to the next level. Definitely, it will rule the market in the next 5 years. That is what I predicted, and currently it is ruling also. And there is no competitor as of now for the Snowflake. Trust me, really, I'm telling. Okay, so that is about the performance. Next, coming to second one, concurrency. Now, what do you mean by this concurrency, Siva? Okay, let me try to compare with the traditional database, that is Oracle or SQL Server. Okay, let me compare with the Oracle first. So, when multiple people are trying to query, when multiple people are like executing select query on a Oracle database, Oracle database will not give that much performance. Database will start crying actually. Okay, so the performance will go down slowly as the number of users are going up. Okay, but in Snowflake, yet a time, if 100 people are trying to query, or 500 people are trying to query the data, or 1,000 people are querying the data, irrespective of number of people, it will give the same performance to each and everyone. That is the beauty. Shiva, how did it got that performance? Because of the virtual warehouses, because of its internal architecture. I'll talk about that architecture after this slide. Okay, so that is the concurrence actually. Snowflake can give the answer for thousands of people at a time, I can say. That is nothing but your concurrency. Okay, no performance degradation at all. That is one. And next, elasticity. Okay, one more thing. I told you, right? When multiple people are trying to execute the query in a Snowflake, the database performance will go down, right? But in Snowflake, it will not happen. You know what? You know what is the reason? Because of the virtual warehouse concepts, or because of the internal architecture. Okay, so at any point of time, you can increase the hardware capacity in Snowflake. At any point of time, you can decrease the hardware capacity in Snowflake. That is in your control. If you don't want to control that one, you can give that choice to Snowflake also. Snowflake will take care of that increasing the number of hardware, decreasing the number of decreasing the number of servers. That is the beauty with this one. Instantly you can scale up, you can scale down. Hardware capacity, I would say. You'll understand slowly what exactly mean by that. When I get into like virtual aerosis concept, you'll understand it slowly. When I start showing the UI, right, you'll understand that. Okay, so that is one of the benefit actually. Next, simplicity. What do you mean by this one, simplicity? If you take traditional databases, If you take traditional any traditional database, you can take Oracle, SQL Server, MySQL, Postgres, anything you can take, guys. What we have to do traditionally, what we used to do is we have to install the database in a server. In that server, we need to place it in a room. To that server, we need to provide a continuously power supply, continuously network. We need to give the network connection to that, and we need to maintain some AC or cooling power to that, and somebody has to monitor the performance of the database. All those things are required for the traditional databases, but I would say that none of these things are required for Snowflake. None of these things, whatever I mentioned for the traditional databases, not none of these things are applicable for Snowflake, because we don't need to install anything in a server. We don't need to maintain any room. We don't need to maintain any network connection. We don't need to maintain any power supply. We don't need to maintain that application. We don't need to monitor the health of the Snowflake. Nothing is there required. We just need to create an account with the Snowflake and start using it, boss. That is the beauty. Very minimal configuration is required. Nothing to do. Just create an account, start using it. And administration is also very minimal thing in Snowflake. Very, very minimal thing. Okay. And no performance tuning also very, 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 very little, I can say. Nothing, not that much is required as much as your traditional databases. Okay, that is nothing but your simplicity. And next, last one is, moreover, it is RDBMS. RDBMS is nothing but relational database management systems. That means, I mean, it is more likely like your RDBMS, traditional RDBMS only. That means you don't need to have any specialized skills to learn or to become a master for Snowflake in Snowflake. You just need to have SQL skills. That's it. SQL skills. That's it. If you know basic SQL, you don't need to you don't need to have any master in SQL. If you know basic SQL skills, that is enough to become a master in Snowflake. Okay, you don't need to have any specialized skills for that. That is the beauty. That is the advantage with the Snowflake. Okay. Next, moving on. These are all the advantage benefits, guys, when you compare with the traditional databases which are available in the market. Okay. Next, moving on. Okay. All these are different customers who are all using Snowflake in the market. Guys, this is very old slide, I would say. When I started my course like 4 years back. Okay. This is almost my 21st batch. When I started my first batch, I prepared this slide. At that time, I captured this slide from the their website. At that time, 4 years back, 3,000 customers were there. Now, definitely, it would have crossed 7,000. My gut feeling is it would have crossed definitely more than 7,000. So most of the people are started using, most of the famous companies started using the Snowflake as a data warehouse. Most of the companies are migrating towards the Snowflake from the traditional data warehouses. Okay, that is one thing. Okay. Now, this is the architecture of the Snowflake, guys. And before I get into Snowflake, if you have any questions, you can ask me related to subject, guys. Don't ask me related to the course and all. Just so far, whatever I discussed, you can ask the questions. Yeah,
Okay,
somebody.
I have one question.
Are there any cons of the Snowflake? Of course, Meghna, to answer your question, every technology has its own pros and cons. None of the technology is master or they're great in the market. Of course, we have some cons for Snowflake, but they're negligible, I would say. Slowly they are trying to improve from their end. Snowflake people are, when I started teaching, when I started working with the Snowflake, right? when I compared with those days, actually, now Snowflake has improved a lot and lot. So even if you have some cons, of course, they're slowly minimizing those things.
Yeah, thank you. I mean, I was just curious to know because sometimes, for example, we compare Java and Python, we understand what are the pros and cons.
Yes,
I
yes,
wanted
yes.
to know why Teradata or Redshift is being used instead of Snowflake. So there could be something better in them. Just
I'll talk about that features also. Now, after the architecture, I'll talk about that features also. What are all the additional features it is giving? I'll talk about that.
sure. Thank you.
Yeah, yeah, yeah. Any other question, guys? Feel free to ask. Ashok, to answer your question, is it OLAP or OLTP? I would say that it is both. So my answer is first it is OLAP. After that, I would say it is OLTP. Recently, they made it public as OLTP. Okay. Yeah.
Okay. So, Shiva, as you said that the Snowflake will take care of for data storing based upon our business data.
Yeah.
So, how they are going to provide the data security of our data? As I
I'll
may.
come back to that. Once I start explaining the architecture, I'll come to that.
Okay.
Your question will be
Mm,
answered definitely soon.
And one more thing is,
Mm.
as you said, the Snowflake is a semi-ETL tool, right?
Yeah. Yeah.
Generally, if you go for informatica and data stage,
Mm,
we
mm,
have
mm.
some set of tools that you are going to use and build a job and set
Yeah.
up a
Mm,
pipeline into the
mm,
backend
mm,
DB.
mm.
So how here Snowflake is useful? Like here also we can have a
Yes. Yes. We don't have the drag and drop mechanism which we have in traditional ETL tools, but still we
mhm.
can build such kind of pipelines with the help of SQL commands. Okay, and with the
Okay,
help of, we can integrate the Snowflake with the Airflow. We can build the pipeline. We can schedule them. We can create the procedures, and we can schedule them.
okay, all right,
Okay, you
yeah,
can
yeah.
build that definitely. I'll show you that one as well. Okay, I mean, once we
Okay,
get into the actual subject, I can show you that one. But definitely we can build the pipeline.
sure, sure. Thank you.
But
Yeah.
we will not get that luxury or flexibility that we get in Informatica or other ETL tools.
Mhm. Okay, and one more thing is, say for example, if you in our relational data type, it's a structured data type.
Hmm.
So we are going to store the data in the form of rows
Yes,
and
yes,
columns.
yes.
Say for example, as you know, right, in the Hadoop, it can be supported for
Mm,
structured and unstructured
mm,
data.
mm, mm,
So
mm.
how Snowflakes will support
Yes, I'll come
for
back to that
structured and
point as well. Yeah, Snowflake can store the data in a structured format, semi-structured format, even unstructured also supported when they started like integrating Snowflake with Python. It can deal with the
okay,
unstructured data as well.
mm, correct.
Did I answer
All
your
right.
question?
Yeah, yeah. I
Mm,
understand.
yeah.
But
Now,
Python
Snowflake can be
also.
integrated with the data lakehouse.
Mhm.
Lakehouse can store the data in a unstructured, semi-structured format and structured format as well.
Okay,
See, most of the
got it.
data we
Because I
store like in a 90% of the industrial industries are like storing their data either mostly in structured format. 10% of the cases they would go with the semi-structured format, and very like minimal cases to store the data in a unstructured format. But still, Snowflake is supporting that.
okay, got it. Yeah,
Yeah.
thank you, sure.
Mm. Yeah. Moving on, guys. Let me complete the architecture. After that, we'll wind up. Okay. Yeah. Let's finish it off. Mm. And this is very important interview question, guys. When you attend any interview, they'll ask you what is the architecture of the Snowflake. Can you explain the architecture of the Snowflake? Please try to focus on this one. My sincere suggestion is, when you start learning any new technology, please try to understand its architecture. Please try to understand that. Okay, without understand the architecture, don't get into the technology. When I start, usually when I start learning, when I heard any technology, right, I would first go through the architecture, so that you'll get high level idea what exactly mean by the technology. Okay, now after I explain this architecture, you'll come to know many of your questions will be answered. I know some of the people, they have the questions in their mind. They're like, they may not ask that question. They feel that, like, whether can I ask this question or not, this is relevant question or not, or this is related or not to this one. Oh, okay, such kind of all those questions will be answered here. Okay, let's get into that. Snowflake architecture basically contains 3 layers. First one is database storage. Second one is virtual warehouse or data processing layer. Okay, and third one is cloud service layer. Okay, now, so what do you mean by these layers? What does they do actually? How can you compare with these traditional databases, this architecture? Okay, let me first come back to the database storage. Okay, I told you, right, Snowflake is a cloud data warehouse. Data warehouse means we have to extract the data from different OLTP system and we have to store it somewhere, right? Now, where does Snowflake stores the data? Do they have any data centers in the backend? So you're saying that it is a cloud, right? Do they have any data centers in the backend? How do they store the data? My answer is, they don't have any dedicated database in the backend, data centers in the backend. Then how are they storing that? Boss, Snowflake is tie up with the public clouds which are available in the market. That is AWS, Azure, and GCP. They are storing their data. Snowflake people are storing their data in. If you choose AWS as a cloud provider while creating an account, they store the data in a S3 buckets in the backend. Okay, if you choose AWS as a cloud provider, they store your data in a S3 bucket. This is a AWS storage service. Simple storage service. S3 is full form is simple storage service. Yes. Okay, if you choose Azure as a cloud provider, they store your data in a blob. BLOB. They store your data in a blob. So this is the storage service of the Azure. This is the AWS storage service. If you choose GCP as a cloud provider, then they store your data in a GCP bucket. GCP bucket. So this is the storage service of the Google. What I wanted to say is, Snowflake does not have any dedicated data centers in the backend. They tie up with the public cloud services. They are AWS, Azure, and GCP. They are indirectly storing their data in a public clouds. Okay? Yes, that is okay. Shiva, how much of data we can store in a data warehouse? In traditional databases, actually, they support only either 2 TB, 10 TB, 100 TB, or 400 TB maximum, or 500 TB maximum. But how much Snowflake support actually? Do we have such kind of limitations here? No, boss. You can store unlimited data in a Snowflake. The storage is virtually unlimited. We don't have any limitation on that. You want to store like 500 TB? You want to store 1000 TB of data, you go and store it, no problem. You just need to pay rent for that storage. That's it. We need to pay rent. That is about your database storage. Now, coming to the second layer, that is data processing layer. Now, what is this, Shiva? What is this data processing actually? Okay. In order to execute your query, let's say you're writing some query, guys. Select star from EMP, select star from sales. In traditional databases, who is executing your query actually? Your system or server is trying to execute that query. Your processor is trying to execute that query. But in our case, who has to execute that query? Ultimately, Snowflake is a SQL only, right? Ultimately, backend we are going to write SQL queries only, right? So who has to execute that one? Backend, some hardware should be there, right, to execute. Some processor should be there, right, to execute that one. That hardware or processor, we call it as a warehouse, virtual warehouse. That system, that server, we call it as a virtual warehouse. Here, actually, we process our data. Okay, this is what I was trying to say. At any point of time, we can increase the number of servers. At any point of time, we can decrease the number of servers to process your data at any point of time. That is instant. Just like that, we can increase the number of servers. We can decrease the number of servers. So here, actually, you're going to process your data. Processing means when you write a query, let's say select star from sales, where sale date equal to 01/01/2024. It has to execute that. It has to apply that filter condition, right? That filter condition, that order by, when you try to write a order by order data, order by invoice data, order by department number, when you try to write that one, it actually fetches the data from the database. It orders the data in this layer only. It will process your data. That is nothing but your data processing layer. So this is a hardware layer, I can say. Okay. Okay. Now, Siva, you told us, right? Like you have some servers here. Are we really storing our data in these servers? No, boss. No, it is just a hardware. That's it. Just a hardware. That's it. There is no relationship between this hardware and the storage. These two layers are completely independent to each other. These two layers are completely independent. They're decoupled. They're loosely coupled. In traditional databases, actually, these two layers are tightly coupled. What do you mean by that one, Siva? That means, if at all, if you want to increase the storage, you have to increase your hardware capacity. If at all, if you're increasing your hardware capacity, automatically or indirectly, you're increasing the storage capacity. But in Snowflake, that is not the case. Both are completely decoupled here. They're completely independent to each other. You can increase this hardware at any point of time. You can increase the storage also at any point of time. No relation. This is because of this unique architecture. I mentioned, right, even 1,000 people are trying to log into Snowflake and trying to execute the queries. No chance of performance degradation because of this architecture only. Okay. Now coming to the third layer, that is cloud service layer. Now, what do we do in this layer actually? Here, we actually maintain all our cloud related activities. What are all the cloud related activities, Shiva? That means ultimately, cloud point of view, virtual warehouse is nothing but VM. VM. In Azure, we call it as a VM. In AWS, we call it as a EC2 nodes. See, compute power is nothing but some processor is nothing but some system, right? Node, right? Some system right in the backend. That system in Azure language, we call it as a VM. In AWS language, we call it as a EC2 nodes. Okay, that is nothing but one service, right? In AWS or Azure. That infrastructure, this storage infrastructure is completely managed by this infrastructure manager. Snowflake is going to maintain that in the backend. Snowflake is an application, that's it. That application is going to maintain those two services. Okay, now coming to this one, optimizer. This is the brain or heart of the Snowflake. So when you write a query, how the query has to be executed, how much of data it has to scan, that will be decided by this optimizer. This is the brain, or this is the heart of the Snowflake. I'll talk about this optimizer in upcoming sessions, guys. Okay, this optimizer plays a crucial role, I can say, for executing your query. Okay, that is about the optimizer. And the next one is metadata manager. When you store some data in a storage, let's say you're creating some tables, like a sales table you have created. Okay, let's say customer table you have created. Let's say your what do I say? Location table you have created, invoice table you have created. All those tables, metadata, columns information, like table information, constraint information, and the cluster information, everything is maintained by this metadata manager. This is completely managed by Snowflake only. The tables or database related data is maintained by metadata manager. And the last one is security. Just like your traditional databases, here also we can go ahead and create users. We can go ahead and give the permissions on the tables. We can go ahead and create the roles. We can go ahead and implement the RLS, row level security, column level security, masking, all security related aspects we can maintain. Somebody asked just some time back, Shiva, how securely it is going to store your data. The moment you load the data into Snowflake, it actually uh, it actually encrypts your data, I would say, so that nobody can hack your data. Your data is fully secure. That is what the assurance the cloud people are giving to us. If they don't give that assurance, guys, we don't store our data in the cloud, that to public clouds. Especially banking related kind of clients, they're really scared to store their data in a public clouds if they don't give that assurance. But Snowflake is strongly saying that no worries, boss, your data is fully secure. If you feel that we don't store our data, we are ready to do the signature. We are ready to give that SLA. At any point of time, your data will not be breached. That assurance we are giving. That's what they say that always. The moment you store your data you start your storing your data in a Snowflake, it will be encrypted. Okay, and next one is authentication and access control. What do you mean by this? I told you Snowflake is just an application. We need to create an account. When you create an account, you will give some username and password, right? When you try to log in into that. So back end, somebody has to authenticate that, right? Whether username and password correct or not. that authentication will be taken care by authentication and access control protocol. That is also maintained by Snowflake. Now, what would I say is finally, the cloud service layer is completely maintained by Snowflake. Rest of the two layers, they are taking help from the cloud. Rest of two layers actually they're depending on cloud, and this layer is completely Snowflake is maintaining. Snowflake is just an application, that's it, in the backend. Okay, so moving on, I'll try to explain one more slide, guys. After that, I'll give you time to ask questions. This is what I was trying to talk here. We have centralized storage. All your databases data will be stored at one place, either in S3 or Blob or GCP bucket in the backend. On top of that one, we have hardware. All this, okay, this is one hardware actually. This is one server actually. This is one more server. This is one more server. This is one more server. Okay, all these servers can come and access the data from Snowflake any point of time. All these servers actually can come and write the data into the Snowflake table any point of time. There is no locking concept while writing the data in Snowflake. Very deeply, I'm going to discuss those concepts, guys, once we start like discussing the real concepts. Okay, so this is your hardware layer I was talking, query processing layer that I was talking, and the optimization, metadata management, the overall infrastructure management, transactions, security, metadata management will be taken care by your last layer, that is cloud service layer. Okay, this is storage layer. This is your query processing layer. This is your cloud, like a cloud service layer. Okay. Now moving on to the next one. Just a second, guys. This is not required. Huh. Sure. Someone was asking, right? Hey, like, what are all the advantages, or what are all the other beneficial things that we have with the Snowflake? I'll quickly talk about the benefits and the features of the Snowflake, guys. What exactly it is giving? Okay, so it is giving instant and unlimited scalability. I've already talked about this. Instant means at any point of time you can increase the hardware. Guys, even if you don't understand the increasing of the hardware, decreasing of the hardware, don't worry. Since this is first class, since you are not got into the actual subject, you'll understand it slowly. Don't worry. I'll make you understand about all those things. Don't worry. Okay. And next one is unlimited scalability. That means you can spin up almost 1024 servers at a time. That is nothing but virtually unlimited scalability. That means 1024 systems can work on your systems like just like that. Quickly you can do that one. That is the beautiful feature provided by the Snowflake. I told you, right? In this is centralized database actually. Any data warehouse, any hardware can come and access your database, can come and write the data into the database any point of time. For each and every department, for each and every team, actually, we are going to create a dedicated virtual warehouse and we'll give the access to them. That's it. All these teams are independent to each other. Centralized database we have here. Don't think that, okay, marketing team data we store at one place, and finance related data we store at one place, and sales related data we store at one place. No, we have a centralized database actually. Okay, this is one feature. And one more thing is, Snowflake has a tie-up with almost all the ETL tools, all the clouds which are available in the market. This is one of the reason why Snowflake has become very popular now, nowadays, guys. You see any ETL tool, you see anything in the market, Snowflake has a connector. Snowflake has a connector for almost all the tools, 90% of the tools, guys. See, I've just mentioned only some of the tools, 10 to 15 tools here. But if you open documentation, you have like almost 100 plus like tools are available which has tie-up. With Snowflake has tie-up. Okay. Next up. When was it actually came into the market? Okay. Okay. Before I'll talk about that one tomorrow anyway. Before that one, I'll just talk about the features here. Okay. Shiva, how Snowflake is giving assurance to your data. What if you store your data in one particular data like data center? What if something goes wrong with the data center? Yes, boss, your question is absolutely right. Your question is perfectly valid. Back end, what will happen, when you try to store your data, they don't store your data in one data center. Don't worry what exactly mean by data. If you don't know the meaning of the data center, I'll talk about that one very deeply. Okay. Once you start storing your data, they don't store your data in one data center. They'll try to maintain 3 copies of your data, 3 different data centers. If something goes wrong with your data center, no problem, guys. Immediately they'll try to switch to this particular data center, and you don't even know that they're pointing to this data center. You don't even experience that delay. That is the beautiful thing, guys, here. You don't need to worry about whether the database will crash or not. At any point of time, your data will be available. That's it. That is the SLA they're giving. This is one of the feature they're providing. We don't have such kind of mechanism in a traditional databases, right? Traditional databases, if something goes wrong with that one, right? That's it. All your data is gone. Next. Okay. The beautiful feature that I like really in Snowflake is time travel. What do you mean by this time travel, Shiva? In traditional databases, guys, if you truncate the table, if you drop the table, what will happen? You cannot retrieve the data. You cannot get your data back. But in Snowflake, even not intentionally, if you drop your table accidentally, if you truncate your table accidentally, you can still recover your data happily without contacting your administrator. In traditional database, in production environment, if you drop the table, what will happen? What will happen? You have to contact your administrator and you have to tell them, boss, accidentally I've deleted that. What do I need to do? This is important table to our business. Without this table, our business will be get impacted. Now we have to do at any cost. We have to recover the table. Come on, we have to create a war room and we have to recover this data. Come on, do all these things. Now, those kind of bullshit things are not there in the Snowflake. Without even sending an email to your Snowflake administrator, you can simply recover your data if you have access. That is a beautiful, 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 beautiful feature in Snowflake. None of the in market, none of the data warehouse is providing except Databricks Unity Catalog. None of the data warehouses, none of this cloud is providing such kind of feature. Okay. And we have a facility to clone our data. We can create a multiple copies of your data, guys. This is also one of the feature of the Snowflake. Okay. Next, Yeah, those are the main features, guys. I'll talk about the remaining features tomorrow. Okay. Uh, Now you can start asking your questions, guys, related to the subject. And one more. Okay, one more. I'll just come back to the last slide, guys. Here, remaining features I'll try to talk about tomorrow. Don't drop off. I'll try to discuss the important things here. Hmm. Now you may ask a question here, Shiva. Why do I have to learn Snowflake here? Why do
Shiva.
you prefer this Snowflake only? Why not other tools? Okay. I would say all these reasons for that. Okay. Slowly, industry is moving towards the Snowflake. They started moving their data into the Snowflake, guys. That is happening really. They started their migrating the data from the traditional databases to Snowflake. Especially, I heard many of the projects are like migrating from Teradata to Snowflake. Okay, that is one reason why you guys have to learn Snowflake. Because of that, many projects are there in the industry. Okay, and now still I would say that experts are not there in the industry. I am giving guarantee. I'm giving guarantee. If you put 100% efforts, if you attend my classes regularly, if you complete my assignments regularly, this is like I would say that my responsibility is to make you master in Snowflake. You leave it to that to me, provided you have to do some hard work. Okay, if you enter in this market, you will get more package, I can say. Okay, now next reason why you have to change. If you are already in testing, or if you are already from different background, let's say non-technical background, or like some other background, you can happily switch to the development. You can happily switch to the data engineering field. Data engineering is evergreen, guys. You go and check after my class, you go and check in the internet what are all the top, like I would say technologies and the fields in the market, data science or the data engineering or the web development. What are the different like things are there in the market? You search in the Google, you will definitely get data engineering is one of the field which is top in the market. Okay, you can change your career from your early background. Okay, and this will be there definitely for next 5 to 6 years. I've been telling the same point from last 4 years, guys. Still, the demand is there for this Snowflake. Still demand is there. Okay, and it is easy to learn if you have SQL knowledge. Basic SQL knowledge is more than enough to have to become a master here, and lot of job opportunities. And I'm giving guarantee that I'm giving guarantee, and I'll give you contacts also of my previous students, how they got placed. Many of my students actually came to me with a proxy concept, but I never encourage them to go with the proxy. I've given assurance them to learn in a with a passion, I would say, and they placed in a quickly once they complete their this one training. If you want, I'm ready to give this their contacts as well. Okay, recently one of the student got placed in Salesforce with a package of 53 lakhs. 53 lakhs. I'm proudly saying that. Her experience was 13 years. She got a package of 53 lakhs. If you want, I'm ready to share the screenshot of her WhatsApp message as well. Okay, she got placed initially in Tiger Analytics with almost 45 lakhs plus, and after that she started. I've asked her to try in a product based company, and she tried and she got placed in a Salesforce. That is the biggest, the highest package that I got for highest package for my students. Okay, that is what I'm trying to say, high pay scale. Okay, and this course will be continued for 3 months, guys, and I'm giving a challenge here. You go to any institute, you go to any trainer, you compare with their content, you compare the fees as well, no problem, I don't have any problem. Okay, you take the content, you take the duration, you take the explanation, you take the other things, compare with them, and then only you come to me. And if you don't have a time to spend 3 months of time, please do not join in this course. I'm strongly saying that. If you have a time, if you have a zeal to learn, if you have a zeal to get into data engineering field, come walk with me. I am ready to do hard work, I am ready to give the subject. You guys also have to be ready to take the subject. I know some of my previous batch students also there, they know my capacity, they know my patience, they know my hard work. I don't talk about my capacity, my students will talk about my capacity. Okay, now you guys can continue for this week. I will not ask you a single rupee also until we finalize the batch. Nobody is asking, nobody is going to ask a single rupee also. You guys can continue till this weekend. I'll continue, I'll conduct 1 hour sessions every day. Will go slowly. Okay, I'll not go with a quickly, or I'll not rush actually here. We'll go slowly. I'll make you understand each and every point. You'll understand slowly how depth I'm going, how slowly I'm going, like how I'm making you understand the concepts. Okay, yeah. Now if you have any questions, you can ask me.
Shiva, you said the cloud security.
Can you be a little bit louder? I don't know who is that. It's very, your
Yeah,
voice is
hi
feeble.
Shiva.
Yeah,
Am I audible now?
yeah, little bit. Still your voice is low.
Okay.
Srinivas, go on mute, please. Who is that? Mahesh, right?
Yeah, yeah.
Yeah. Mahesh, go ahead.
So cloud layer, what do you mean by cloud layer here? I mean, if you go back to your previous slides, architecture point of view, so is that cloud layer is meant for like, I mean, Snowflake layer I can consider as?
Snowflake layer, I can say. Yes, correct.
Okay.
Snowflake is going to maintain that layer actually. This is the one.
Yeah.
Yeah.
So
Snowflake
in the
is going
same,
to maintain all these things.
okay. So in the same slide, when
Mm.
it comes to security,
Mm.
we are depending on the cloud provider, right?
Yes, correct.
Yeah. Last question in this same slide is, let's say when it comes to database storage, like last one, what is the data storage, whether it is S3 or BLAB, whatever it may be. So when it comes to concurrent users point of view, let's say I have allowed 500 members at a time to access my Snowflake application or to get the BA report, whatever it may be. So, but is it throttled at storage level, that 500 users? Because I mean, S3 or
Yes.
whatever it may
All
be.
the requests which you are getting from the users are completely isolated.
Oh,
Completely isolated. All the requests are independent to each other. The
so
request will come via only virtual warehouse layer. You'll understand that one slowly. When I start like explaining the real concepts, right? You will understand.
okay.
Definitely. Yeah.
So from virtual layer to database layer also, it will be, kind of,
The execution will go like this, guys. First, whenever you start executing the query, the request will come to the optimizer first. Optimizer will decide what to scan, what not to scan, and how it has to, I mean, what exactly the physical plan and the logical plan. That will be
Got it.
decided here. That
Got it.
logical plan, physical plan will be submitted. I mean, physical plan will be submitted to virtual warehouse. Virtual warehouse will go and get the data from the database.
Got it.
So the flow will go like this.
Okay, got it.
You'll understand. We will have very in-depth discussion about this, the flow.
Okay, thank you.
Yeah, somebody, your voice is not audible. Shivaji, I'm not audible. Am I not audible? Yeah, go ahead. Others. Yeah.
Yeah, Shiva.
Yeah.
So, as you were saying that the database layer and virtual warehouse, those
Mm-hmm.
two layers maintained by cloud servers,
Mm-hmm.
cloud providers.
Mm-hmm.
So, depending on the data which you are getting from the source systems,
Mm-hmm.
load up the source systems, which will automatically increase the virtual servers
Yes.
without
Yes.
facing any
Yes.
performance issues.
Yes.
Say, for example, for a particular day, I got more data. In the
Mm-hmm.
next day, I got less data, just like
Mm-hmm.
an incremental data,
Mm.
full load data.
Mm.
So is it the automatic process
Yes.
which is
Yes.
going to set up manually?
Snowflake has that intelligence to manage the hardware in the back end, to avoid unnecessary cost.
Mm-hmm. Okay.
Okay, the most of the I would say 80% of the billing you'll get only because of the compute power. Okay, that compute power, it will take care in a best way. They have the algorithms in the back end. I'll try to discuss that one also. That algorithms also, how it is going to manage.
Okay. So in that is the case, they are going to charge on monthly basis. Say for example,
Yes, yes, monthly basis only. How you're how you will be charged for the postpaid bill in your in the case of mobile. Same way, how many seconds, how many minutes you guys are utilizing their services, how much data you guys are storing in their database. Based on that, they're going to charge.
okay. Say for example, in a particular day, so they were used 5 virtual servers to load our
Mm,
data.
mm,
In the
mm,
next day, they were used only for the 2 virtual
mm, mm.
servers.
They'll
So
be
they are going to
they'll bill
charge on.
accordingly. Yes, they'll bill
Yeah.
accordingly.
Okay. Yeah.
Yeah,
I have a question again.
yeah.
So you mentioned the data is encrypted before it gets into S3 or blob or
Now,
any.
once it got into S3 or blob or this one, in transit or with data is in a rest, the data will be encrypted in your Snowflake.
Okay, even before it is stored, it is encrypted. Okay.
Yeah. So if you don't believe Snowflake, guys, you guys can go and your own encryption algorithm also. They have given that choice as well. You can generate your own keys and you can manage that one as well. You can rotate your keys as well.
Okay. So in this case, is it like only encryption with keys, or is it also like attaching a certificate and a signature with it?
Only with the keys as of now.
Okay, sure. And second question is, you mentioned about PITR, like point in time recovery. So
Hmm.
let's suppose I'm doing a query, and let's also assume I'm not using a laptop, I'm using a desktop,
Mm-hmm.
and I executed a query. I
Mm-hmm.
saw the results on the screen.
Mm-hmm.
But before I could save or do anything, I just lost the power connection or the internet, and the after reloading,
Mm.
I cannot see the results on the console. Is it available to just see what was the recent query I made, or what was the
Yes, it's a cloud. It's not Snowflake is not installed in your system, right?
yeah.
Nothing will happen. You can happily query the data, even the power is off or internet is. I mean, I would say that you just need to have a laptop with good internet. That is enough to access the Snowflake.
Okay.
Nothing. Your hardware is nowhere related to your Snowflake.
Sure.
How
Okay.
whatever the configuration it is, you can still query your data.
Got it. Yeah.
That means what I mean to say is you don't query the data from the Snowflake with the help of your system hardware. You're going to use Snowflake hardware to query your data.
Okay.
Yeah. Yeah. Any other question, guys?
So we cannot use like an on-premise database or data warehouse concepts, right? So, as you said,
Sorry, I didn't get your question. Come again. We
no,
cannot
we
use
cannot use on-premise database or data warehouse kind of things, right? So
I mean,
we
it's a
have to
cloud
go
data
with,
warehouse, right?
yeah, we have to depend on
It's a
cloud
cloud.
only.
We don't have the on-premise Snowflake concept here.
Oh, okay.
Okay, it's a cloud, purely cloud.
So selecting GCP or Azure or whatever it may be, is that predefined?
Yes, while creating the
tools?
account tomorrow, I'll show that one. While creating the account itself, you have to choose what should be the cloud of your Snowflake.
So is supported, I mean, Snowflake supported clouds only we have to select or any
Yes,
other?
yes. Only Azure, AWS, and GCP.
Okay.
Currently, these three public clouds are supported. No other cloud is supported.
Got it. Thank you.
Shiva,
Yeah.
did you migrate any database into Snowflake?
Yes.
Yeah.
Yes, we have done that. In the real time, from Oracle to Snowflake, we have done. One of the client was using Oracle as a data warehouse, and we migrated the data completely into Snowflake.
So you are going to teach that or how?
Yeah, I'm going to teach that. Srinivas, you wanted to ask any question or go on mute, please?
Sorry, sir.
Yeah. That's all, guys. If no questions, we can wind up. Tomorrow we'll meet at the same time. Guys, you can attend the classes up to this weekend, up to Friday. After that, you guys can decide whether to continue the course or not. Okay, till that time, you guys can attend, no problem. Okay.
Hi, myself
Yeah.
Lakshman. I have one question.
Yeah, go ahead.
Is it possible to share this one PPT so that meantime we'll go through that?
PPT I'll not share, guys. I'll share the recording,
Okay.
today's recording.
Oh, okay.
Okay. Once the batch is finalized, then I'm going to share the PPTs.
Okay. No.
Okay. Yeah.
Fine.
I'm sorry.
Is that-
Sorry to say that.
Yeah, 5 days in a week or how?
6 days in a week, guys.
Okay, thank you.
Because I don't want to prolong the course 4 months or 5 months, because we are going to spend solidly 3 months of time, every day 1.5 hour time. Saturday more time. Saturday 2 hours I'll take. Okay. We'll try to finish off within 3 months.
Okay.
Every day 1.5 hour.
Hi Shiva, this is 3 months is only for Snowflake or
Not
including
Snowflake.
ADF?
Snowflake and the ADF. I'll talk about that ADF also in tomorrow's class.
Okay.
Okay. Yeah.
Can you also include like what is the difference between DynamoDB, Redshift, and Snowflake?
Currently, I don't have that comparison. If you want, I can make that comparison as well in upcoming classes.
Okay. Yeah. Thank
Sure.
you.
Sure. Any other question, guys? Yeah, that's all. Thank you. Thanks for your time, guys. Thank you.
Yeah.
We'll meet tomorrow at the same time. Have a good day.
Thank you, Shiva.
Thank you.